Hello everyone, apologies for not being able to be here today. Of course, it's my job to make sure the weather's good for events like this. Sorry about that, but I guess we can't complain about the moisture, as we like to say. So what I'm going to do is what we normally do is we kind of take a look at the last couple of years, especially the last season, talk about why we had the weather we did and what the prospects are for the weather coming, especially the spring and summer 2023 and maybe a little bit further on down the road. We'll review and talk a lot about the La Nina that's been plaguing the Western High Plains and the Central and Western United States for 3 years in a row now. We really need to get rid of this La Nina to find ourselves in a better situation with precipitation. And unfortunately, we thought at this time last year that maybe La Nina was going to be gone by summer of 2022. Obviously, that didn't happen. We'll talk a little bit about that here in a moment. So the drought of the last 3 years really driven by this 3-year La Nina cycle, where the subtropical Pacific Ocean is colder than average, and colder than average subtropical waters, those waters in the Pacific near the equator, when they're just a little bit cooler, that leads to less water vapor going into the air. It changes the wind patterns across the Pacific, and it's a drought signal. A drought signal in the central and western United States is a La Nina. A La Nina has been responsible historically for our severe droughts, and the last 3 years of drought conditions have really mostly been driven by this La Nina cycle. And we'll talk a little bit about these La Nina cycles, and a lot of times when they go this long, 2 or 3 years, that's when drought conditions are the worst. And we have had three-year La Ninas in the last 30 years. The last time we saw a 3-year La Nina was back in the mid to late 50s. So this is a bit of an unusual situation we have found ourselves in over the last 30 years. We've had 3 multi-year La Ninas, and they've been severe in terms of the drought conditions. The last time we had an El Nino was back in 2019. So these multi-year La Ninas are just nothing but bad news. They lead to drought conditions, and I talked about the last 3 decades, the last 30 years. And so we've got the drought situation we are in right here, the drought in 99 to 2001, and the drought of 2010 to 2012. Those were all periods of time where there was a La Nina that lasted 2 to 3 years. And going 2 or 3 years with a cold Pacific, this leads to less spring and summer precipitation. It also can lead to warmer and drier than normal conditions. As we saw last year in particular, a lot of wind, especially in the winter and spring season, which of course leads to higher evaporation rates. And the wind, as we know, especially in Nebraska and South Dakota and eastern Wyoming, last spring was just absolutely awful. So this La Nina has been plaguing the region. And what we need to do, or what we hope to happen, is maybe see this La Nina fade. And I can't stress enough how important these La Ninas are. I do think in the western United States we're a little bit preoccupied by El Ninos, and that I think has to do a lot with some of the far western parts of the United States, and El Nino cycles tend to get the heavier precipitation, but the heavier precipitation also affects us in an El Nino cycle. When the Pacific is warmer, we tend to be cooler and more wet. But when these La Ninas come in, these multi-year La Ninas, when we see them coming, we need to be prepared for them. So the good news is that when we get out of these La Ninas, we tend to see the weather go the other way. And I think we're starting to see that, and I know we have, with the big influx of Pacific storms that have brought heavy rains and snows to California, parts of the Pacific Northwest. We've started to see the chinks in the armor of La Nina beginning to fade. So getting rid of this La Nina pattern means less of what I'm listing here. It means less in the way of blocking patterns, less in the way of drought signals, and less in the way of conditions that are going to lead to a better outlook. And a lot of times, these multi-year La Ninas, which do bring on drought in the western United States, a lot of folks are going to say that these La Ninas or these colder Pacific decadal oscillations may not have an overall pattern effect. They really do. And a lot of times, like the drought of the last 3 years is sometimes blamed on things like climate change, when really we're going through a natural Pacific cycle. And once we go out of this, things are going to beginning to change. So when we get into these cold cycles, these La Ninas, as I mentioned earlier, less water is available, Less water vapor means drier, droughtier conditions for the central and western United States. And timing is really everything, but if we were to go back and take a look at those last 30 years, even further back, let's go back all the way to 1950, which is right here, 1951, to where we are present day over here. What I want you to notice here is that when the Pacific has these colder cycles, as represented here by these black lines, when they go through these colder cycles, where there's more blue than red bars, which means the Pacific more often than not is colder than it is warmer, we tend to have more La Niñas, and we tend to have less El Niños. If you have more La Niñas and less El Niños, you're going to be in a cycle that is going to be drier. That's what we saw from the early 50s to the late 70s. We saw that period of time, about a 30-year cycle, of droughtier conditions during that time frame. Then we saw things reverse. Notice the Pacific sea temperatures started to go up again, and we had 11 El Niños between the late 70s and the late 90s. We hit a 20-year stretch there where the El Niño frequency went up, La Niña winters decreased. Those La Niñas decreasing meant better precipitation. And then as we got right after the big El Nino, and where you see these big red bars are where you have really strong El Nino situations. Notice though, after a strong El Nino, we tend to have these multi-year La Niñas come into play. And we saw that right around 1999 to 2000. We went from a really warm phase in the Pacific to a much colder one. And this is the cycle we're in now. The cycle we're in now is right back to where we were in the 50s to the late 70s, which was dominated by more frequent La Niñas and less frequent El Niños. Now, the good news is that you do cycle out of this eventually. Whether or not we cycle out of this going into the next few years and see the temperature go back up like this later on, don't know yet or when that will happen. But the good news and bad news of looking at this graph is that the good news is we're going to cycle out of this current La Niña pattern and go into, in the next year or two, it may not happen this year, but certainly it will in 2024, go into an El Nino cycle, which will get us back into more wet weather patterns. But whether or not we're going to be in this cold cycle in the Pacific longer or shorter is something we're going to have to see. And you can really see here when we identify the last 3 decades, when we take a look at these cold cycles in the late 90s to early 2000s, as represented here by these circles, this is when western Nebraska, western South Dakota, eastern Wyoming, western areas of the high plains went through these stronger drought cycles. This goes back to the late 70s to the late 90s. And you see, dominantly, the Pacific was warmer in the key areas. And those key areas would be the subtropical areas near the equator. Then we got into the late 90s and early 2000s, and that dominant feature in the Pacific was colder near the equator, near the tropics. And it's like having an engine in a car with not as much gas in it when we go into these colder cycles, because the equator region of the Pacific Ocean, and really all the oceans, but namely the Pacific Ocean, that equator area and those warm sea surface temperatures provide a lot of energy to the atmosphere. If you're going to have more energy going into the atmosphere, you're going to have more weather. More weather means more precipitation events. These colder cycles are nothing but bad news for this part of the country. So this is what we've been suffering through, not only the last 3 years, but if you add up the last 3 decades, it's been a little bit rough because of these colder cycles. We should cycle out of this eventually, and I think as what we're going to see here going forward is there's some prospect, there is some hope that conditions are going to get better as we go into the next 12 or 24 months. Now, this is where we were about a year ago. This is a sea surface temperature map from early February of last year. And you can see the blue and the green here along the equator showing those colder sea surface temperature anomalies. So a pretty bust La Nina was occurring about a year ago. But as we got into the spring and summer, we started to see some changes. And those changes were reflected somewhat by the forecast that was given for the next upcoming season. So this would have been the forecast I may have showed you a year ago, which showed that anything below the 0 line would be considered colder Pacific and a La Nina. The forecast last winter at this time was for La Nina to slowly fade into summer and then go to neutral status by mid to late summer. That was the forecast that was given based on the modeling of sea surface temperature anomalies. But we all know what happened is this forecast ended up busting completely. And I want to show you kind of what happened throughout the course of this last year to explain the dynamics of the Pacific Ocean and how that really affects things. So if we were to look at the heat content of the ocean, not only at the surface, where we have these sea surface temperature anomalies, but below the water, the depth of the cold water relative to the 30-year average is important because the deeper the cold water, the longer lasting the La Nina. The more shallow it gets, or if temperatures begin to reverse, well, then you're going into possibly another cycle or could be an aberration. So at this time last year, we were somewhat encouraged that we were seeing a trend for the depth of the cold water to get thinner and those warmer sea surface temperatures to develop. And this was right around late January and early February of last year. But look what happened. After we did see in February and early March a little bit of a warming trend in the subtropical Pacific, all of a sudden, those sea surface temperature anomalies dropped off again, and they really tanked. Now, what happened? Why were the models so wrong? What went on here? Well, there's two ways to possibly look at maybe some scenarios that played a role in this. Number one is the computer models could have been wrong. They could have diagnosed the Pacific conditions wrong and just got the forecast not correct, and that certainly is going to happen with any computer model. If you have bad inputs, you're going to have a bad model. Also, I remind you that about in January of 2022, some of you may have heard about the big explosion, the Tonga volcano that happened somewhere near east of New Zealand. Now, it was in the southern hemisphere, but it was a giant volcanic eruption that went high into the stratosphere, putting a lot of water vapor and sulfur dioxide into the lower stratosphere. Now, there could have been a cooling effect because of that volcanic eruption affecting the tropics. That maybe could have been one reason why this La Nina went on for a third year. And this is what the forecast was updated in June. Notice, let me go back to the forecast that was in January, where we basically saw La Nina fading and going away. But look what happened with the forecast when it was updated in June. Well, when it was updated in June, well, we had a different story. The average of all the models kept it all of a sudden near La Nina status before fading right around the early part of winter of this past year. So things changed. Something happened in the Pacific, and look at what happened. While we did see a little bit of a warm-up, a little bit of fading of that La Nina in June to early July of last year, look what happened during the summer. Those sea surface temperature anomalies really dropped. And we got into very strong La Nina status right here. So we did not have any help at all last spring and summer from the La Nina fading. It faded briefly, only to come back in a short period of time. Now, one encouraging thing is you're probably noticing the depth of the cold water is eroding very, very quickly again. So it does appear that this long-lasting stretch of colder than average sea surface temperatures in the subtropical Pacific are beginning to ease. And that's exactly what we're seeing here going forward. Taking a look at the drought monitor a year ago, a couple of things to highlight. As you can see, the western United States very much in early January of last year, very much in severe drought conditions. But notice the drought conditions in Nebraska and this region right here weren't good, but look at where they were a year later. The most recent drought monitor has the drought conditions worsening. If we compare years here, drought conditions worsening across Nebraska, eastern Wyoming, southern South Dakota. Look at the winter wheat areas of Kansas, Oklahoma, into eastern and southeastern Colorado and down into the panhandles. Basically, while we have seen improvements, and I'll show you where those improvements have been, drought conditions, as you know, worsened during the spring and summer of last year in our neck of the woods. If we were to look at the change over the last year, the green areas show where drought conditions have improved. The yellow, orange, and darker colors show where they've really gone south. And you can see that the middle of the western high plains, central high plains here, basically in this area right here with a few exceptions, that's where drought conditions got really, really bad. We did see those spring storms in March and April of 2022, right across the northern tier of the U.S. This is one reason why it was so windy down here during the spring of last year, where these lows were very prominent across the Pacific Northwest going across the northern plains. So if you look at the Colorado Rockies, New Mexico, a large part of Wyoming and Montana, back in the Pacific Northwest, and then in California and Arizona, well, drought conditions actually in the past year have gotten better. But we're right here on the boundary, the edge of where drought conditions still persist and are still very stubborn. And if we were to make a little bit of a closer look at what's going on, you can see where the improvements have been, where conditions haven't improved, and where conditions have certainly gotten worse. This is where we are right now. The most recent sea surface temperature anomaly still shows those colder waters near the subtropical Pacific. However, as I'll show you here in a minute, they're not as deep as we saw in this graph right here, where we see the erosion of the depth of the cold water going away. So when we see that, we're encouraged by the most recent forecast that came out in December. The green line here is the average of all the models. And what it's showing is the green line going above the zero line, which takes us out of La Nina status and puts us into where we would call it La Nada, or neutral status here by late spring and summer. The sooner we get rid of La Nina, the better that's going to be for spring. The one wild card we've got going into the spring and summer season is how quickly this La Nina will fade away. If it's stubborn, if we go into, let's say, late March, but especially April, May, June, and it's still there and not going away completely, that's not gonna be as beneficial if it's gone, or let's say goes to neutral status by March or April. So timing is really critical. And we look at the forecast here. Again, this is based on modeling, the same model that got it wrong last summer, so we have to take it with a grain of salt. But what we do see here is the probabilities of an El Nino, this is represented by the red bars, really starts to trend up by late winter and spring right here. The blue bars represent the probability of La Nina continuing. So you can see that it basically flatlines while this one really goes up strongly. Now, the odds of a 4-year La Nina are low. It would have to take something like that Tonga volcanic eruption or another big eruption maybe near the equator to cause some problems and some cooling in the tropics. So we're more optimistic than we were a year ago that things are going to be changing. And boy, things changing has really boosted snowpack. Snowpacks are off to a fabulous start. These are the snowpack water equivalents, SWEs, as of the 16th for Wyoming. And you can see the green and the blue. You see green and blues, you're off to a great start. The darker the blues, the more water that's in there. Colorado, the same situation, except here in the southeast. And if you look at the entire western United States, there's going to be a lot more water going into the reservoirs this runoff than we've had in probably 3 seasons. So we're already seeing some chinks in the armor of La Nina. This response we've seen in the stormy weather moving into California is really part of the equation of the Pacific starting to show these changes. And we are benefiting, like what we're seeing outside right now, we're benefiting from some of this Pacific moisture right now across the western high plains. If you were to look at the last 90 days of precipitation across the west, this is the amount of rain or snow melted, water equivalent that's fallen going back to basically the middle of October here to the middle of January. And if you look at the precipitation anomaly, anywhere you see brown, you see, or red, precipitation's been below average for the last 90 days. Green and blue means above average. The brighter the blue, the darker the blue, the more it's been. You can see California there. But you can also see other areas of the Dakotas, central and western Nebraska, parts of Wyoming and Montana. Actually, the last 90 days has been wetter than normal, as evidenced by the big snow drifts out in the parking lots right now. There's just been a lot of stormy weather early this winter season. Now, that's caused a lot of problems, but this water and this trend that we've seen changing really should help. So let's take a look at what those sea surface temperatures may do going over time. I want to show you what is forecasted, at least by the modeling, on what will happen here in the subtropical Pacific, this area right here along the equator, north and south of the equator. We want to see the blue fade away, and we want to see these orange or yellow colors to really come into play here to see things go away. So this is where we are now. as we get into February, you see it weakening. By March, it weakens. And notice by April, you notice the sea surface temperature anomaly right here has reversed. What we're seeing here is a reversal of fortune. Basically, La Nina weakening, the depth of the cold water gets thinner. And then this is by May, this is by June, and this is by July. So what you're seeing is basically by July, maybe, and I'm going to put a question mark here because we got burned last year thinking it was going to go away. But it does look like we're going to at least be in neutral status. If we do get into an El Nino, it may not be until late summer, but certainly as we go into 2024, the idea that an El Nino will replace the La Nina is looking pretty good, which ultimately is good news in terms of better precipitation, also not as hot for the western high plains as we get into the next couple of growing seasons. So when we go to an El Nino, it's the reverse. Basically, it's the exact opposite. More water vapor is available, the trade winds directions change, so more moisture is pushed to South America and North America, and you're going to get more precipitation in the west. Also, the monsoon season, where you get those thunderstorms in the summer season, which is responsible for a lot of our rain that falls in July and August. Well, the sea surface temperature anomaly forecast here in the key areas, right here, this is the key area here, the second key area, number 2 there, is the Gulf of Mexico. But right now it's predicting that by July, the sea surface temperature anomaly up here in the Gulf of California, the Gulf of Mexico, this is going to lead to what should be an okay monsoon season. Whether or not it gets this far north, well, we saw it stay in Colorado last year, in New Mexico and Arizona, where they got a lot of rain last summer. But if it gets to be robust, and if we do have better soil moisture conditions this spring and early summer, that bodes well for western Nebraska, western South Dakota, and eastern areas of Wyoming. So if we were to kind of use the analog technique of looking at what has happened historically to what should happen going forward, using a mixture of our modeling and a mixture of what we've seen in the past, La Nina will finally go away. Pretty confident of that. The question will be is when it goes away. If it hangs on and is stubborn, that's going to be bad news. We should, though, go into a new alternating El Nino-La Nina cycle. So if we do get into an El Nino, maybe by the summer or by fall, we should go into a cycle that would lead to an El Nino most likely in 2024, maybe going into 2025. So this bodes well. If this trend continues, precipitation this spring and summer should be better than the last 3 summers and springs. There is the potential of a cool, wet spring on the table, and I'll show you that here in a minute. We're likely, in the last days of this month and into February, have some pretty cold weather in the central and western United States. It looks colder than normal for the rest of January and probably for February. And if that colder pattern is associated with some moisture, and we carry some of that better soil moisture into the spring season, that bodes well for better summer precipitation as well. Some of the modeling sees that. Now, what I'm showing you here is for the next month and a half. So this takes us from where we are today through early March, the first couple of days of March. If you see the green, green means the probabilities of above average precipitation are good. White means average precipitation. The brown and the reds mean below average precipitation. So California gets a chance to dry out during the next 45 days while these storms and these weather systems will continue to be active in our region here. So this is a rather encouraging forecast for the last days of this month, February and into early March. But of course, it's going to be March, April, May, and June that are going to be those critical months in terms of precipitation. But this is something good to see. And look at temperatures. This is what we mean by the trend looking colder. It really does look like the central and western United States is going to have a cold late January. And for the month of February, I think even into early March, there are signals that the last half of winter and early spring is more often not going to be colder. And you would expect that. If La Nina continues to fade, that's what you would expect to see. If this happens, we should have less wind this spring. I'm not saying no wind, but we should have less wind this spring, which would be good news for everybody. This is the 90-day forecast of February 1 through the end of April. So you can see where the tendency or the probability of a colder than average spring, February through April here, is showing on up. And if you look at precipitation February through April, lots of green there. less in the way of brown, more in the way of green across our region. So it could be an active spring. When you have a colder spring, you usually have a wetter spring. When you have a warmer spring, you don't tend to have those precipitations. So taking a look at longer term, if you want to stay informed on these ocean cycles, which I believe is a real key to understanding our drought and wet cycles here in the Western High Plains, these are some websites to go to. For some of you out there, you may be listening to the podcast I produce Monday through Fridays. Keep in track with the podcast because we talk about sea surface temperature anomalies, and we'll be able to track La Nina and see whether or not it indeed fades and shifts into an El Nino cycle or not. And if you want to look at some of those graphics I showed you, put in your search engine, whether it's Google, DuckDuckGo, or whatever. If you type in IRI space CPC, you'll get to some of those websites that I showed you that show those forecast updates, and they are updated once a month. Around the middle of the month, let's say usually between the 15th and the 20th, is when the new forecasts come out on these La Nina and El Nino cycles, and they rerun the models to see what is going to happen going forward. So in summary, I am optimistic that the spring and summer season in western Nebraska, eastern Wyoming, western South Dakota is going to be more wet, and I think we've seen that with the stormy weather we've endured this winter so far. There's going to be more of it, and if we do see these colder than average conditions, livestock interests, you're going to have some more rough days. I know it's already been a long winter, but I'm afraid it's going to stay a long winter with the rest of this month, February, and into spring being an active pattern. But the silver lining is going to be the precipitation that comes along with it. If anybody has any questions, feel free to send me an email at dot@dayweather.com, and I'd be more than happy to reply with any questions you have. Again, apologies for not being able to be there today. Have yourself a good rest of your afternoon.